Hello, everyone. Welcome to the Engineering Bart Show. I hope you enjoyed that that little music there. It was done by the Bart himself. He's about my height, a little bit overweight, brown hair, in his 50s, I think. Anyways, so we're gonna talk about adding a button to the Mbed. This is actually a little bit more challenging than you think because I'm a little bit behind on my videos, is because this thing gave me a little bit of problems, and I thought it was simple, but there is so exclusively. Please pay attention because this other literature out there may leave you astray and it might not work. Okay, so here's the assignment. We're going to have 3 LEDs, 1 button. There's going to be a red, a blue, green, and what it is, when the button is pushed, the red LED will flash 5 times, but the blue and the green LEDs will turn off. Once the LEDs start flashing, the circuit will resume. Assume that other LEDs will blink for 1 second. So the red and blue will keep on blinking. This is sort of like an alarm system. Very crude alarm system. Nevertheless. Okay. Stop the video, design, code, and build. I put this on here because a lot of you may work for somebody, and this is all you get is just an assignment. Go ahead and build it, and good luck. And if you don't build it, there's the door. All right, but that's the reality of it. Okay, so go ahead and build it, design, code it, and now let's get the parts. So we need LEDs. This is a picture of the LEDs. 1 battery. We won't need that, by the way. I put that star there. It's optional, but you won't need that. 1 normally open toggle, not a toggle switch, but a normally open button switch. I purposely crossed out that 100K resistor. That is supposed to be a pull-up resistor. We are not going to talk about that because we will talk about it, but we're not going to. It's just keep it in the back of your mind. It's not part of it's not really part of the lesson, okay? So, and we want 3 ohm resistors. So, digital in is a command that only accepts voltages around 3.3 volts range, but with low current. That's actually not true now. There has been an update. The reason why I put that in there, because you'll read some literature about that. That is also in the Arduino. I remember trying to get the buttons to work Arduino. It did exactly the same thing. So I will show you at the end of the video. Update: the digital in is always 3.3 volts and is waiting to go to 0. So it's the exact opposite of what, and so it's sort of misleading of digital in, because you're expecting in some kind of input and you're expecting like maybe the current goes in, but that's wrong. It's doing the opposite. In this experiment, the button we're going to use digital in. That is true. So here's an example of initializing. You type digital in, my button, or whatever button 1, button 2, PC 0. I just picked that one. You could pick PC 0 all the way up to 15. And let's go ahead and stop the video, and we're going to code and design. And I'll see you at the AutoCAD section. All right, we're at the code section. This time I got pretty much everything all set up. However, this circuit is built wrong, but I will show you the right circuit. But let's go ahead, and you're going to see. So let me go ahead and let's go ahead and put some finishing touches here, okay? So all right, so let's look at the text box right here. All right. Oops. There we go. Let's call this SW1. SW1. All right. Let's kind of shrink that. I get overexcited. Okay, it's a little small. That's okay. We're going to scale this sucker right here. There you go. pull that baby. It's a little bit large. Scale it again. Right about here. That's perfect. Okay. Click, enter. There you go. That's the switch, okay? All right, let's go put some finishing touches right here. Okay. You guys should be building it, by the way. So while I'm talking, build it, or just go ahead and stop the video and build it. Come back to this, you know. You could do. You guys could do whatever you want. You know what I mean? Okay, so. Okay, close the hatch. I don't want that. It's on text. Okay, let's go ahead and do that. All right. Okay, so you have to you have to zoom in a bit, otherwise it won't. There you go. Enter. Okay. Okay, now we're gonna actuality. This is good news because this is a pull-up resistor design. You see the battery comes in, and then there's the 100K ohm resistor, and then it goes to PC4, and then it goes to ground. Now, the old designs are that way, and there's a lot of old literature that way. Exclusively, we don't need this. I found out that this is actually not the right way. So let's go ahead and delete. Oops. Delete. Delete. We're going to delete all this good stuff right here. We're going to keep that. Delete. 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 Delete that. Delete. Delete. Delete that wire. And that node's fine. And that's all we need, believe it or not. So this is the final design. All we need, the switch, connect to PC4, and it's hooked to ground. And that's it. And that's actually good news of the update, because now we don't need an external battery source, which it's providing that. Okay, so I'm gonna zoom this out. Go ahead and take a screenshot of that. I'll give it just a screenshot. Just hit the print screen right there. Put it on your Word file. That will help you out. Go ahead and build it. And let's go to the code talk. All right. So let's get into the code part. This is the pre-code. And I think this is always a good thing. A lot of people don't do this. I do it. And so I want to be, I like to go the extra mile. Okay, here we go. So what we're going to do is we're going to declare the pins, call the GPIO pins LED on PC0, 1, 2, 3, declare a switch. We're going to define the time, define iterations 5, define 1, 2. We're going to set up a void function called the alarm. The alarm is where it's going to blink 5 iterations, and then it'll turn off the other LEDs. We're going to run forever. If the switch is pressed, then else call the alarm, else the yellow and green LEDs will blink, and this will go run forever. So let's go down. I even put this up there. There's the old flow diagram. We're going to declare pins. Very simple stuff, by the way. Very simple stuff. And then this is actually inside. This is outside the main. Okay, it's outside the main where we set the alarm up. And then has the button been pushed? Yes. Then it calls the alarm. If not, it will blink. Keeps going around and around for forever. All right. So let's go. Now let's go to where everyone. Let's go to the real code. All right. See you there. All right, so here we are. We got everything all set up. I got the file, simple one button going on. We make sure the targets are there. I already got the thing all. We're making a fake alarm system. That's not really a great alarm. So let's call it digital out. Digital out. What I put it as? Yeah. Yellow LED. And that will be PC 0. All right. PC 0, semicolon. Another one is a digital out. And I think it's a green LED. Uppercase green. And that is PC1, I believe. PC1. What? Oops. Okay. Take out those brackets. Okay. And now we got a digital in, excuse me. SW1, we call it our switch SW1, SW. And that we're going to do that PC. Oh, excuse me. We're going to do digital out red LED. I forgot there's that red LED. And that's PC2. PC2. All right. And we're going to do digital in. Digital in. Oops. Out. What did I say? Out. In. Button. Kind of put it in reverse there for a second. Got to get my brain in gear. Okay. Lowercase button. PC4. PC4. Okay, so we're declaring our variables. That's what we're doing right outside the main. Let's go ahead and put in a couple constants here. Define time as 1 million. Oops, what did I put 9 for? 1 million is lowercase d. 1 million. I put in reverse. I do this sometimes. Get kind of. Okay, and we got define. We're going to define inc, as increment, as 5. Okay. And then, okay. All right. Now we're going to get a little bit fancy here. We're going to put a void alarm on the outside. And now we're going to put a for loop pretty soon as I start moving my fingers. For int I equals 0, if I is less than my increment, then I plus plus. Okay, and let's go ahead and set the alarm up. So the red LED that's right. We forgot to define our states. On equals 1, define if on, if off equals 0. Okay. Red LED equals on, semicolon, wait function, the infamous wait function. And it's time. I capitalize it. Okay, put capital time. Okay, semicolon, and then red LED equals off. Okay, gotta put the wait function again. Copy. Oop, there it is. Copy. Paste. And then we want to turn turn the others off while this is happening. It turns the system off. Okay. Okay, so now we're going to get to the button part. So if I don't know what I was, let me grab something. Hold on, I think something fell on the ground. Ah, there we go. Okay, I'm back. If button 1 is on, and it's equals on, not assigned to on, then alarm turn on. So that'll turn on alarm. Else, sometimes I like the else, but sometimes else can be hindering. In this case, we'll see. We'll have to test it out. I got copy and paste it because I don't like to type. So there you go. I'm probably going to copy paste the weights function. There we go. Weights. I copy and paste. And let's copy and paste the weight functions just one at a time. Paste. And then let's go ahead and paste again. All right. Now let's change our states. Let's go ahead and compile it. All right. There it goes. No errors. That's good. That's always good. And look at all that stuff working in the background. All right, so let's see what the code looks like. Okay. So this is an update, okay? So I was having some issues with the code that I just had. Make sure you put pull up for PC4 pull up. There's one up above, so make sure you put that. So I changed it to the button equals to 0, and you notice I took off the else loop, and that right there is the code. So take out the else, change it to 0, and everything will work just fine. Thank you. Let's go to the proof section. All right, so there you go. They're blinking back and forth. But I know that's not enough. I know. You said there was a button. Okay. Let's see what's going on here. You're going to see my hand. What's going on? I hit the button. What's going on? How come it's not working? Wait a minute. Now it works. Okay, now it's blinking. But you see how I had to hold that down? See how I hold that down? That's a problem that we have on a very high responsive rate. See? It doesn't respond. Doesn't respond. But when we hold it down, then responds. So anyways, I have a confession to make. I'm going to get on one knee, and I want to say that I want you to subscribe to my channel. Thank you. Bye-bye.